Hello world and welcome to Hacks. In this video we're going to be continuing the red team learning path on TryHackMe, and we are now looking at C2s. Task 1, Introduction. Welcome to Intro to C2. Command and control frameworks are an essential part of both red teamers and advanced adversaries playbooks. They make it both easy to manage compromised devices during an engagement and often help to aid in lateral movement. Room objectives. In this room we will learn about command and control frameworks in depth to gain a better understanding of the following topics: how a command and control framework operates, the various components that you may use, how to set up a basic command and control framework, use Armitage or Metasploit to gain familiarity with command and control framework, how to administer a command and control framework, OPSEC considerations while administrating command and control frameworks, and much more. Room prerequisites. General experience with the Metasploit framework. For more information, see the Metasploit module. General familiarity with red teaming. For more information, see the red team fundamentals room. General familiarity with exploiting vulnerable machines. And we don't have to answer a question now, we just have to mark the room as complete. Task 2, Command and Control Framework Structures. Okay, prior warning, there is a lot of information in this section and it's probably going to take me a while to get through it. I'll try and rinse through it as fast as possible, but I probably will trip over my words and mess up a bit, but here we go. What is a Command and Control Framework? While trying to digest the various components of a C2 framework may be intimidating, however, they don't need to be. In order to better understand what a C2 framework is at its most basic level, think of a netcat listener, the C2 server, that is capable of handling many reverse shells all calling back at once, C2 agents. It's a server built for reverse shells. Unlike Netcat, almost all C2 frameworks require a special payload generator. This is usually a feature that is built into the framework itself. For example, Metasploit is a C2 framework that has its own payload generator, MSF Venom, which I fully plan on doing a tools video about in the future, maybe sooner than later. You can see there, you've got your various victims that have been infected. They're sending netcat or just reverse shells back to the command and control center, which is where you'll have your netcat listener, and then you've got your very evil and sinister looking C2 operator. The diagram above depicts 3 compromised clients calling back to the C2 server. So what exactly makes C2 frameworks better than normal netcat listeners? It seems like some of them need to do is implement some session management into Netcat and you have the same thing. Well, that's true. C2 frameworks shine in their own post-exploitation features. Command and control structure. C2 server. In order to understand a command and control framework, we must first start by understanding the various components of a C2 server. Let's start with the most essential component, the C2 server itself. The C2 server acts as a hub for agents to call back to. Agents will periodically reach out to the C server and wait for the operator's commands. You can see there you've got your 3 servers all communicating back to the C2 server with the malicious attacker. Agents and payloads. An agent is a program generated by the C2 framework that calls back to a listener on the C2 server. Most of the time this enables special functionality compared to a standard reverse shell. Most C2 frameworks implement pseudo commands to make the C2 operator's life easier. Wow, I can't read today. Some examples of this may be pseudo command to download or upload file onto the system. It is important to know that agents can be highly configurable with adjustments of timing of how often the C2 agents beacon out to the listener on a C2 server, and much more. Listeners. On the most basic level, a listener is an application running on a C2 server that waits for callback over a specific portal protocol. Some examples of this are DNS, HTTP, and HTTPS. Beacons. A beacon is a process of a C2 agent calling back to the listener running on a C2 server. Obfuscating agent callbacks. Sleep timers. One key thing that some security analysts, antivirus and next generation firewalls look for when attempting to identify command and control traffic is a beaconing and the rate at which the device beacons out to the C2 server. Let's say a firewall observed traffic that looks like so. So you've got some various packets there, but if you notice it's going up in 5-second increments, so 5, 10, 15, 20, 25, that would create a pattern, which is very obvious to anybody analysing the traffic, that it's not human, it's clearly periodic. A pattern is starting to form. The agent's beacon out every 5 seconds. This means that it has a sleep timer of 5 seconds. Jitter. Jitter takes the sleep timer and adds some variation to it. Our C2 beaconing may now exhibit a strange pattern that may show activity that is closer to an average user. Yeah, because you don't refresh a web page every 5 seconds or do a specific request every 5 seconds. You can see there 3, 13, 14, 23, 27. So by randomizing it, you then make your actions or your bot's actions seem a lot more human and, you know, lower the suspicions. The beaconing is now set to a semi-irregular pattern that makes it slightly more difficult to identify among other regular user traffic. In more advanced C2 frameworks, it is possible to alter various other parameters like file jitter and adding junk to data or payload files being transmitted to make them seem larger than it actually is. Sample Python 3 code jitter may look like the following. So you import the random module, you set your sleep value to 60, and then you set your jitter value to random integer minus 30, 30, and then you do sleep equals sleep plus jitter, so that it takes that random integer, adds it to the sleep at 60 seconds, and does whatever with it. It is important to note that the fundamental example, but it can be much more math heavy, setting upper bounds and lower bounds, taking percentages of the last sleep and building on it from there. Because this is an introductory room, we will spare you the complicated formula. Thank you. Payload types. Much like regular reverse shells, there are 2 primary types of payload you may be able to use in your C2 framework: staged and stageless payloads. Stageless payloads. Stageless payloads are the simplest of the 2. They contain a full C2 agent and will call back to the C2 server and will begin beacon immediately. You can refer to the diagram below to gain a better understanding of how stageless payloads works. So yeah, victim executes payload and it starts beaconing initially, instantly. The screenshot depicts a stageless payload calling back to the C2 server. The steps for establishing the C2 beaconing with a stageless payload are as follows. The victim downloads and executes the dropper being a malicious file. The beaconing starts to the C2 server. Staged payloads. Staged payloads require a callback to the C2 server to download additional parts of the C2 agent. This is commonly referred to as a dropper because it is dropped onto the victim machine to download the second stage of our staged payload. This is the preferred method over stageless payloads because a small amount of code needs to be written to retrieve the additional parts of the C2 agent from the C2 server. It also makes it easier to obfuscate code and bypass antivirus programs. As you can see there, you've got the various steps. Stage 1, the victim downloads the dropper and executes it. Stage 2, the dropper calls back to the C2 for stage 2. That's there, yep. Stage 3, the C2 server sends back to the victim workstation. Stage 3, this is all getting a bit, yeah, stage 2, stage 3. Stage 4, the C2 is loaded into memory on the victim's workstation. C2, the beaconing begins and the red team of threat actors can engage with the victim on the C2 server. Payload formats. As you may know, Windows PE files, executables, are not the only way to execute code on a system. Some C2 frameworks support payloads in various other formats. For example, PowerShell scripts, which may contain C# code and may be compiled and executed with the add type commandlet. HTA files, JavaScript files, Visual Basic application scripts, Microsoft Office documents like macros and things like that, and many more. For more information on various payload formats, you should review the weaponization room in the initial access module. Can't wait to do that. Modules. Modules are a core component of any C2 framework. They add the ability to make agents and the C2 server more flexible. Dependent on the C2 framework, scripts must be written in different languages. Cobalt Strike has aggressor scripts, which are written in the aggressor scripting language. PowerShell Empire has support for multiple languages. Metasploit modules are written in Ruby, and many others are written in many other languages. Post-exploitation modules. Post-exploitation modules are simple modules that deal with anything after the initial point of compromise. This could be as simple as running sharphound.ps1 from Bloodhound to find paths of lateral movement, or it could be as complex as dumping LSAS and passing credentials in memory. For more information on post-exploitation, refer to the post-exploitation basics room. Can't wait to do that one as well. Pivoting modules. One of the last major components of a C2 framework is its pivoting modules, making it easier to access restricted network segments within the C2 framework. If you have administrator access on the system, you may be able to open up SMB beacon, which can enable a machine to act as a proxy via the SMB protocol. This may allow a machine in a restricted network segments to communicate with your C2 server. So I assume that's like some sort of firewall evasion because SMB traffic is allowed. You can set your listener or something up as an SMB protocol, and because that's allowed through the firewall, it can get out onto the network, out onto the internet. Let's have a look. This diagram depicts multiple victims with an SMB pivot calling back to the C2 server. The above diagram shows a host within a restricted network segment call back to the C2 server. So where's 1? The victim calls back to an SMB named pipe on a victim in a non-restricted network segment. Yep, so that's a non-restricted network segment, I assume. Yes, it's calling back to that. The victim in the non-restricted network segment calls back to the C2 server over a standard beacon, so sort of using that as a proxy, going back to the C2 server. 3. The C2 server sends the commands back to the victim in the non-restricted network, and because that is allowed to access the restricted network, the victim in the non-restricted network segment then forwards the C2 instructions to the host in the restricted network. Yeah, so a bit like proxy chains or something in that effect. You're pivoting through this host here to communicate with your C2 server and back. Facing the world, one of the most important obstacles that red teamers must overcome is placing infrastructure in plain view. There are many different methods to do this, and one of the most popular methods is called domain fronting. Domain fronting utilizes a known good host, for example Cloudflare. Cloudflare runs a business that provides enhanced metrics on HTTP connection details, as well as caching HTTP connection requests to save bandwidth. Red teamers can abuse this to make it appear that a workstation or server is communicating with a known trusted IP address. Geolocation results will show whether the nearest Cloudflare server is, and the IP address will show the ownership as Cloudflare. So yeah, if you don't know, if you do a whois lookup on an IP address, it will show you who that IP address is registered to and who it's registered with, whether it's like Aramaic or things like that, or 2Ks and things. And yeah, using Cloudflare is a content distribution network, CDN, and a lot of people use it to protect their sites from distributed denial of service attacks and things like that. So it's not uncommon to see requests going to and from Cloudflare or Cloudflare IP addresses. So if you are putting a host in Cloudflare or using Cloudflare's CDN, that may not raise as many suspicions because you would sort of inherently trust IP addresses within Cloudflare. So that way you can mask your domain through Cloudflare. So joesc2.com can be sat in Cloudflare using its DNS servers, hiding the true IP address of my malicious C2 server behind it because it's using Cloudflare's IP addresses to mask it. As you can see there, we've got a little bit of a diagram. The diagram shows an example HTTP beacon from a compromised device. The diagram depicts how domain fronting works. So where's number 1? C2 operator has domain controlled proxies through Cloudflare. Number 2, the victim beacons out to the C2 domain. So the victim beacons out. Number 2, yeah, oh, I see that. So the compromised device beacons out to Cloudflare. Cloudflare proxies the request, then looks at the host headers and relays the traffic to the correct server, this is our malicious server here. The C2 server then responds to Cloudflare with the commands, and then the victim receives the commands from Cloudflare. So Cloudflare is our middleman. C2 profiles. The next technique goes by several names, different products: Nginx reverse proxy, Apache mod proxy, mod rewrite, Manable HTTP C2 profiles, and many others. However, they are more or less the same thing. All of the proxy features more or less allow a user controlled specific elements of incoming HTTP requests. Let's say an incoming connection request has an XC2 server header. We can explicitly extract this header using specific technology that is at your disposal, reverse proxy mod blah 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 blah, and ensure that your C2 server responds by a C2 based responses. Whereas if a normal user queried the HTTP server, you might see a generic web page that isn't all independent on your configuration. So what this is talking about here, I believe, is virtual host profiles. So if you've ever worked in hosting industry or set up your own web servers, you could know that you can have multiple websites on the same IP address. Now, how do you do that without all of them getting confused? Well, when you send a request to a server, you have a header in there which tells you what sort of domain it is you're looking for. This is a very simplified version. So then when it reaches the server looks at the header and it's been like, oh, you want Joe's domain, and then it can access the corresponding web space for that domain name or the correct directory. So apologies for butchering all the words there, but that's effectively what it is. It's using virtual hosts on the server. Like Nginx is a reverse proxy that allows you to sort of tell Nginx where specific websites are, so that when a request comes in for that specific area, it knows where to get it. And you got a diagram there. A compromised device and security analyst reach out to a C2 server. Only the compromised device gets a C2 beacon back. The analyst gets Cloudflare website back. So let's have a look. Where's one? So, device send HTTP request to the C2 domain. The victim beacons out to the C2 server with the custom header, the HTTP request, while the SOC analyst has a normal HTTP request. Yeah, so you got your SOC analyst and your compromised device. The requests are proxy through Cloudflare, so they're both going through there. The C2 server receives the request and looks at the custom header and then evaluates how to respond. So that's then looking how its virtual hosts are configured. The C2 server responds to the client and responds to the analysis with different pages. Because HTTP requests are encrypted, extracting specific headers, XC2 or host may be impossible. By using C2 profiles, we may be able to hide our C2 server from prying eyes of a security analyst. For more information on how C2 profiles can be powerful, see this blog post, Understanding Malleable C2 Profiles for Cobalt Strike. Task 7 will explain and explore other techniques called redirectors. We will gain hands-on experience in configuring Metasploit and Apache 2 to demonstrate how redirectors set up. Well, that was a mouthful, and I apologise for sort of stumbling through a few words towards the end there. But we've got some questions now. What is the component name that live on the victim machine that calls back to the C2 server? We know that's an agent. That's an agent that sends the beacon. What is the beacon option that introduces a random delay value with a sleep timer? So remember we were talking about how that Python module can generate a random integer and then they calculate the jitter based off of the sleep. So the answer is jitter. What is the term for the first portion of a staged payload? So the first portion is the small bit, it's just the code that downloads the actual more malicious code and execute it. That part is called the dropper. What is the name of the communication method that can potentially allow access to a restricted network segments that communicates via TCP 139 and 445? So if you know anything about your ports, you'll know 139 and 445 is server message block or Samba, and so that's going to be the SMB beacon. Yeah, I enjoyed all this information in this room. It was quite dense, there was quite a lot of it, very informative, and it's nice to see how like normal sort of technologies are being used in malicious ways, or potentially non-malicious. I mean, you could just use it to control all your servers, right? Your genuinely own servers. Task 3. Common C2 frameworks. Common C2 frameworks. Throughout your journey, you may encounter many different C2 frameworks. We will discuss the few popular C2 frameworks that are widely used by red teamers and adversaries alike. We will be dividing these into two sections. Free and premium. You may ask questions like, why would I use a premium or paid C2 framework? And that's an excellent question. Premium or paid C2 frameworks usually are less likely to be detected by antivirus vendors. This is not to say it's impossible to be detected, just that open source C2 projects are generally well understood and signatures can be easily developed. Using premium C2 frameworks generally have more advanced post-exploitation modules, pivoting features, and even features requested that open source software developers may sometimes not fulfill. For example, one feature of Cobalt Strike offers that most other C2 frameworks don't is the ability to open a VPN tunnel from a beacon. This can be a fantastic feature if a proxy does not work well in your specific situation. You must do your research to find out what will work well best for your team. Free C2 frameworks. Here we go, our favourite. The one everybody uses, Metasploit. The Metasploit framework, developed and maintained by Rapid7, is one of the most popular exploitation and post-exploitation frameworks, C2, that is publicly available and installed on most pen testing distributions. You can see there you got the MSF console. Fantastic. Armitage. Armitage is an extension of Metasploit framework. It has a graphical user interface and is written in Java, and it's incredibly similar to Cobalt Strike. That is because they're both developed by Raphael Mudge. Armitage offers an easy way to emulate and visualize all of your targets. Aside from looking a lot like Cobalt Strike, it offers some unique features. One of the most popular can be found in the attacks menu. This is a feature known as the Hail Mary attack, which attempts to run all exploits for the service running on a specific workstation. Armitage is really fast and easy hacking. Yeah, you can see there's Armitage there. I remember when this was first in development, Darren Kitchen and Hack5 had Mudge on to talk about it, and it's come a long way since then. That's sort of how far I go back into learning about hacking and stuff like that. I knew absolutely nothing back then. Still don't know anything, but yeah, I remember seeing this like first pop up on Hack5 ages ago, and yeah. It's just nice to see how far it's come, and now that it's gone premium with Cobalt Strike. Anyway, PowerShell, Empire Starkiller. It's another incredibly powerful C2, originally created by Harmjoy, 6dub, and Enigma03 from the Verus group. Currently, the project has been discontinued, but has been picked up by BC Security team. Coin, Hubble, Vinny Bod. Again, my apologies. Empire features agents written in various languages, compatible with multiple platforms, making it incredibly versatile C2. For more information on Empire, we recommend you take a look at PowerShell Empire Room. Definitely one to check out. And that just looks really sleek, doesn't it? It's a nice sort of window. You got your little Death Star there. Just looks nice and sleek. Covenant by Ryan Cobb was the last free C2 framework we'll be covering. By far, it is one of the most unique C2 frameworks written in C#. Unlike Metasploit and Armitage, it is primarily used for post-exploitation and lateral movement with HTTP, HTTPS, and SMB listeners with highly customizable agents. Again, that looks sleek. Very nice. It's nice to have like web GUIs for these things or actual nice windows. Anyway, Sliver by Bishop Fox is an advanced, highly customizable multi-user CLI-based C2 framework. Sliver is written in Go, which makes reverse engineering the C2 implants incredibly difficult. It supports various different protocols for C2 communications like WireGuard, MTLSS, HTTPS, DNS, and much more. Additionally, it supports BOF files for additional functionality. DNS Canary domains for masking C2 communications, automatically lets encrypt certificates, generations for HTTPS beacons, and much more. That's powerful. The fact that you can just automatically get Let's Encrypt certificates for HTTPS beacons. Wonder how Let's Encrypt feel about that, you know, with certificate revocation statuses and things like that. Not sure if that's relevant, but I imagine if you're using it for malicious purposes, that might be naughty. Paid C2 frameworks. Cobalt Strike by Help Systems, formerly created by Raphael Mudge, is arguably one of the most famous command and control frameworks next to Metasploit. Much like Armitage, it is written in Java and designed to be flexible as possible. For more information, see Cobalt Strike's video training page. It offers additional insight into both Red Team operations and the framework by Raphael Mudge himself. Yeah, so it's a premium version of Armitage. I've not used it. I can't wait to actually get my hands on it and have a look, but I've not really used Armitage myself either, you know, I just use Metasploit. Brute Rattle by Shetan Nayak, apologies if I said that incorrectly, or Paranoid Ninja is a command and control framework marketed as customizable command and control center, or a C4 framework that provides a true adversary simulation-like experience with being a unique C2 framework. For more information about the framework, the author has a full training page that demonstrates many of its capabilities within the framework. This looks cool. This looks like something you'd see in a movie, you know, Hollywood hacker movie, where you just bring up a terminal and you just pound everybody. Other C2 frameworks. There's a more comprehensive list of C2 frameworks and their capabilities. Check out C2 Matrix, a project maintained by George Osilis and Brian Bort. It has far more comprehensive list of almost all C2 frameworks that are currently available. We highly recommend that after this room you go and check it out and explore some of the other C2 frameworks. And there's no question to answer there, it's just these are different C2 frameworks, these are what they are, these are what they do. Let's have a quick look over here, the C2 Matrix. Okay, and then you've got all these different, okay, it's not that many. Must be missing something here. I recently tried using Chaos, but I didn't get along with it. I just couldn't get the damn thing to work, but I think that says more about my own ability than anything else, right? Yeah, C2s, they are your command and control centers. Anyway, a lot of information in here, a lot of fun. I can't wait to get my hands on Armitage and give that a go. Task 4, setting up a C2 framework. Let's set up a C2 server. In order to gain a better understanding of what is required to set up and administer a C2 server, we will be using Armitage. As a reminder, Armitage is a GUI for the Metasploit framework, and because of this, it has almost all aspects of the standard C2 framework. Note, if you're using the attack box, you may skip to the R environment setup section. So, I am going to use the attack box, and the reason why is I've tried doing this all locally, and it doesn't work. I get to here, I think, or maybe a bit further down, and it just errors every time. I've tried troubleshooting it for a few hours, and this video has just been going on for too long for me to continue troubleshooting it. I had no issues installing it locally, but then you get problems with the listener because the listener listens on 0.0.0.0. So yeah, it becomes a problem. So all I'm going to do is I'm going to start the attack box, and then once that's started, I'll go through the installation, and then we'll see how we get on. So the first thing I'm going to do is I'm going to split it to full screen, so we get that up there. I'm going to head back over here and I'm going to minimize that view, and then we're going to go straight down to environment. Paranoid environment. So we need to systemctl start Postgres SQL. So let's grab a terminal. Let's hit return on that. Let's grab another terminal. Let's try and zoom in a little bit, and then we're going to do sudo systemctl start Postgres SQL. Fantastic. Then we're going to head back over here, and what do they want us to do next? So they want us to switch to user or Ubuntu, because we need to switch to Ubuntu user, and then do msfdb, and then delete the standard configuration. So first of all, we're going to do su Ubuntu, and then we're going to do msfdb, and then it was --use -defaults delete --use -defaults delete. That'll take a minute. Brilliant. And then we're going to do msfdb, and then --use -defaults, and then we're going to do init to initialize a new database. See, that's creating all the tables. This might take a while. It's trying to start the web service, but it doesn't need to. This will inevitably fail, but it just takes a while. I wish there was like, there probably is a skip you can add to it. Instead of using -defaults, you can probably do like skip web. There you go. Now, on to the next bit. You need to switch back to root and then jump into the Armitage releases Unix directory. So in order to start, we're just going to do exit, and then we're back as root, and then we're going to do cd opt Armitage, and then was it releases, and then Unix. Fantastic. We're going to ls on that, and then you can see we have a number of IP addresses, unfortunately. Now it looks like it's going to be listening on the 10.0.69 one, so I'm going to go ahead and use this one. Yeah, so we need to do /team server your IP, and then we set a password. So we are going to do /team server, then we're going to do 10.10.117.47, and then we're going to set a password of just password1, and then this should generate a certificate for SSL connections. And start in the MSF RPC daemon. So now it's sleeping, waiting for the MSF RPC daemon to initialize. Now it's starting the Armitage team server, and you can see that the Armitage team server is now running on 10.10.117.47 on that port with the username MSF and the password of password1. Feel free to connect to. Armitage is ready for collaboration. So does it actually walk us through connecting to it? So once your team server is up and running, we can now connect to it. So if we open a new tab, we're already in Armitage. Is this the actual directory we need to be in? Yep, Unix. So we should just be able to do Armitage. Fantastic. Then this should pop a window open, and we already know the details because it's already in this tab. So we just have to grab that IP address, wherever the damn window is gone. Is that port correct? 555-553. 555-553. It's got the correct username, so we just grab the password. Whoops. God damn it. Okay, let's not Control-C this time. So, we know that one. That's already correct. That's already correct. Let's grab the password. Let's pop that in there. Let's try and connect to it and see what happens. The service fingerprint is blah blah blah. Does this match? Yeah, why not? Ends.22. Start 7FC. That sounds good to me. What is your nickname? So I'm just going to give myself the nickname of Joe, and I'm going to click OK. Joe has joined the room. Now we're getting the base directory, and now we can see Armitage is finally up and running. I'll tell you what, I had a lot of issues getting this to work. Not on the attack box, but on my own box. I just couldn't get it to listen on the other IP address. I couldn't even get the team server to work properly. So yeah, that's that question now done. We can go into task 5, C2 basic operations. C2 Operation Basics, accessing and managing your C2 infrastructure. Now that we have a general idea of how to set up a C2 server, we will go over some basic operational details that you should know when accessing your C2 server. It's important to note that you are not required to perform any actions in this task. This is meant to be as a general experience and familiarity with command and control frameworks. Thank God for that. Basic operational security. We briefly touched on this in the last section. You should never have your C2 management interface directly accessible. This is primarily for you to improve operational security. It can be incredibly easy to fingerprint C2 servers. For example, in versions prior to 3.1.13 or 3.13, Cobalt Strike C2 servers were able to be identified by an extra space, or 20, at the end of a HTTP response. Using a static binary, using this tactic, many blue team could fingerprint all the Cobalt Strike C2 servers publicly accessible. For more information on fingerprinting and identifying Cobalt Strike C2 servers, check out this article on Recorded Future blog. I can't see the additional space at the end. I do see a 20 in there. The point in mentioning this is that you want to reduce your operational security risk as much as possible. This ties into the previous room where you would do an OPSEC on your own resources. If this means not having the management interface for your C2 server publicly accessible, then by all means you should do it. Accessing a remote C2 server. This section will focus on how you can securely access your C2 server by SSH port forwarding. If you have port forwarded with SSH before, feel free to skip over this section. You may not learn anything new. For those familiar or unfamiliar with SSH port forwarding, it allows us to either host resources on a remote machine by forwarding a local port to the remote server, or it allows us to access local resources on a remote machine we are connecting to. In some circumstances, this may be for circumventing firewalls. Yeah, so you can see that he's trying to get to TCP 8080 and the firewall was blocking TCP 8080. So then he does a SSH into the box and forwards 8080, so all traffic comes through TCP 22, sorry. Now that we have a better understanding of why we want to SSH port forward, let's go over how. In our C2 set up from task 4, our team server is listening on localhost TCP 55553. In order to access the remote port 55553, we must set up a local port forward to forward our local port to the remote team server. We can do this with the AL flag and right, so there's no point in us actually doing this because we're not in a position where we can access the IP address. That's gone a bit funny. Yeah, so we're not actually in a position where we are going to be able to access this IP address. Because well, I suppose maybe if we connect to the VPN, maybe we could do it, but I'm not sure. So yeah, we can't connect to that. So there's no real point to us actually doing the port forwarding. But I can tell you that I've done this plenty of times, especially with Nessus. So a lot of times when you're on a job, you'll have Nessus installed on a remote machine and you have to port forward it back, or even when you're testing web applications on an internal network, you need to port forward the traffic back so you can access it on your local machine. Now that we have SSH remote port forward set up, you can now connect to your C2 server running on TCP 55553. As a reminder, HaXeZ does not support listening on loopback interfaces 127 blah blah blah, so this is general C2 server admin advice. You will find this advice more centric to C2 servers like Covenant, Empire and many others. We highly recommend putting firewall rules in place for C2 servers that must listen on public interfaces so that only intended users can access your C2 server. There are various ways to do this. If you are hosting cloud infrastructure, then you can set up a security group or use a host-based firewall solution like UFW or IP tables. So with the security group, I think they're talking about things like AWS and Azure, where you can set up security groups, which are essentially like firewall rules, which controls the inbound and outbound traffic to and from the resources that you're hosting. Creating a listener in HaXeZ. Next, we're going to move on to the topic that all C2 servers have, this being listener creation. To stay on topic, we will demonstrate how to set up a basic listener with HaXeZ, then explore some of the other theoretical listeners you may encounter in various other C2 frameworks. Let's create a basic interpreter listener running on port TCP 3000-1337 Elite. To start, click HaXeZ on a drop-down menu, go over to the listener section, and you should see three options: bind, reverse, set our host. Bind refers to bind shells, you must connect to those. Reverse shells are shells that connect back to you. After clicking reverse shell, a new menu will open up, prompting you to configure some basic details about the listener, specifically what port you want to listen on and what type you want to select. There are two options from shell and Meterpreter. Obviously we'll choose Meterpreter. Shell refers to standard Netcat style reverse shell, and Meterpreter is the standard Meterpreter reverse shell, and we like Meterpreter because it has all those built-in features. So we're just going to go on HaXeZ, listeners, reverse shell, and then we're going to do, I think they said 3001-337, and then they said they wanted it to be interpreter, and then all you have to do is start listener. After pressing enter, a new pane will open up confirming that your listener has been created. It should look like the standard Metasploit exploit multi-handler module. So if you've done any rooms before, this should look familiar to you. You can see there, use multi-handler is ready, it's running. We've probably do run options on it, and that will show us how it's set up. Funny enough, it's still set to 0.0.0.0. I had this problem, I had this problem when I was able to set it up locally. It was still listening on our host 0.0.0. So, but then that should go to all ports, surely, right? Okay. After setting up a listener, you can generate a standard Windows interpreter reverse TCP shell using MSF Venom and set localhost to the HaXeZ server to receive callbacks to our HaXeZ server. So, yeah. I mean, we won't actually be doing anything with this, but it'll be fun anyway. So, if we go into this tab, we know the IP address is that one ending 47, so we just paste that there. Whoops. Can we not copy and paste? From the different windows. Is that really what's happening here? No way. Okay, so MSF Venom, and then it's -p Windows interpreter -p Windows meter reverse _TCP and then we do our host equals, and then our port equals what, 31337. Our port equals 31337, and then type format is exe, and then output is shell.exe -o shell.exe, and hopefully I haven't thumbed that too badly, but that should generate a exe file which you could drop on a Windows box, save the shell.exe, brilliant, file shell.exe should say Windows executable or PE32 executable. Yeah, and if you drop that on a Windows system which had no defenses in place, it should be able to connect back to our HaXeZ server, and we should get a connection back. But as we don't have a target on this one, that's pretty much all we can do with it at the moment. After generating the Windows interpreter reverse TCP using MS-Venom, we can transfer the payload to a target machine and execute it. After a moment, you should get a received callback from the machine. Okay, so now we're talking about listener types. As previously mentioned, standard reverse shell listeners are not the only ones that exist. There are many variations that use different protocols. However, there are a few common ones that we will cover. Let's begin with the following. Standard listener. These often communicate directly over raw TCP or UDP sockets, sending commands in clear text. Metasploit has full support for generic listeners. HTTP and HTTPS listeners. These often front as some sort of web server and use techniques like domain fronting or malleable C2 profiles to mask C2 servers. When specifically communicating over HTTPS, it is less likely for communications to be blocked by a next-generation firewall. Metasploit has full support for HTTP and HTTPS. I think that's because it can't do packet inspection and it can't check what's actually being communicated if you're using HTTPS, but I might be wrong because of the encryption. DNS listeners are popular techniques specifically used in exfiltration stage where additional infrastructure is normally required to be set up, or at the very least a domain name must be purchased and registered and a public name server must be configured. It is possible to set up a DNS C2 operations in Metasploit without the help of additional tools. For more information, see Interpreter over DNS presentation by Alexei Sinstov and Maximum Andrinov. Apologies. These are often very useful for bypassing network proxies. Again, if you haven't seen my video on DNS tunneling, I highly recommend it. It's pretty good, if I don't mind saying so myself. SMB listener. Communicating via SMB name pipes is a popular method of choice, especially when dealing with a restricted network. It often enables more flexibility, pivoting with multiple devices, talking to each other and other devices reaching back out. Can you tell I'm tired? I really can't read properly today. Metasploit has support for name pipes. Brilliant. Then we got some questions. Which listener should you choose if you have a device that cannot easily access the internet? DNS, and that's because most system or network administrators will leave 53 open because they need to communicate with the outside world. So if you can bury your malicious traffic inside DNS protocols, it will go out through the firewall. Which listener should you choose if you are accessing a restricted network segment? SMB. We spoke about SMB beacons earlier, how if SMB traffic is allowed, you can communicate over SMB and send, it's a bit like pivoting. Which listener should you choose if you're dealing with a firewall that does protocol inspection? HTTPS. Again, I think that's due to encryption. And that's it. We can now move on to task 6, Command, Control and Conquer. Task 6, Command, Control and Conquer. Sample exploit. Host enumeration with HaXeZ. Before letting you go off on your own, we're going to demonstrate how to exploit a sample virtual machine. First, we'll execute a port scan with HaXeZ by going to Host section, hovering over Nmap scans and selecting Quick Scan. Now you can see there, I'm waiting for the IP address of the target machine to show up, but as soon as it's done that, we'll be able to run the Nmap scan. Okay, so you can see we have the IP address there, 10.10.10.151.142. I'm just going to make a note of that elsewhere. And then we're going to head back to HaXeZ, and then we're going to do hosts, Nmap scans. What did it say to do? Was it just a quick scan? Yeah, let's just do a quick scan. And we're going to paste the IP address in there. Fantastic. Does it want to see the range as well? Let's have a look. So it's saying to do /32. So we're going to do the same. And we're just going to click OK. And then we're going to resize the window again. Scan complete. Use attacks, find attacks to suggest applicable targets. So we can see there we find 47. I don't think that's the box we're supposed to be attacking, if I'm being honest. Let's get out of this full window quickly. So we're supposed to be going after 142, I'm sure. After pressing OK and waiting a moment or two, you should be able to see a new tab opened up called Nmap. A new machine displays in the workspaces window, and in the Nmap tab you will see the raw scan results. So, I don't see... Right, so we've got 22, HTTP, LDAP, okay. Maybe this is the box we're supposed to go after. Interesting. What I'm going to do is I'm just going to Nmap scans, quick scan, 47. I'm just going to scan that. Even the right box? No, 142. They did not... Oh, okay, right. Scanning myself. Right. Hosts, Nmap scans, quick scan. It's that silly copy and paste nonsense again, isn't it? So if we do 10.10.151.142 and click OK, just scan that. Scan complete. There we go. There's the box, and you should see there one host up. Although it doesn't show. Interesting. Let's go back to the lab. After pressing OK and waiting a moment, you should see a new tab opened up called Nmap and a new machine display in the workspace window. In the Nmap tab, you'll see the raw scan results, but we don't see any of that. Now that you've learned how to execute a basic port scan, try to execute various other scans against the target and see what additional information you can retrieve from the host. Okay, so Nmap scans. Let's do a comprehensive scan on 42 and click OK. That'll take a while, but you can see that it's actually doing like Nmap. It's doing an Nmap connect scan. You see we found a bunch of ports now. Doing SU, so that's UDP -T4. So yeah, it's doing a TCP connect scan. Exploitation in HaXeZ. Next up, we're going to show off exploitation in HaXeZ. Our victim in an example is a Windows 7 machine, more specifically blue. This machine is vulnerable to the classic exploit Eternal Blue. To find this, we'll focus on the far right tab. Looks like the left tab to me. To find this, we'll focus on the far right tab with the folders, and we'll expand the exploit drop down and then find Windows drop down and then SMB drop down. Then you will find all the exploits. So if we go to exploits, let's drag this over a bit and then go to Windows. This is going to get in the way a bit. And then SMB. You can see there you got all your MS17010 PSExec, so that's your Eternal Blue PSExec.psh. Right. Next up, you can double click the exploit of your choice or drag and drop it onto the host and the new window up, click on up launch and fire off the exploit. Do we not need to set up a listener or anything like that? I'm just going to try and do that. After clicking launch, you will notice the exploit tab open up. HaXeZ will run all of the regular checks that Metasploit normally does. In this case, Eternal Blue, it ran a standard check script followed by the exploit script until it got a successful shell. It's worth noting that the default in this exploit is chose a bind shell. Make sure you fully read the exploit information and open up, see if the bind shell or reverse shell. I apologise for my reading of this. It's, again, I'm blitzing through it. I'm going to cancel that one because I think they use PS exec, so I'm probably going to do the same. So they use su exec. They're on Android though. What? Yeah, okay, let's just go with that and see what happens, I suppose. Use reverse connection, show advanced options. Let's launch. Right, okay, so it now looks like we've finally compromised the host. Hopefully this connection remains stable. We can interact with the session, upload, pass session. Let's go back to this. Make sure I've got enough time left on my box, which I should have. If I just go quickly up to show split and try and add some time. Okay, so I still got an hour. So it looks like we successfully exploited that box. Exploitation and HaXeZ. Yep. After clicking launch, you will notice the exploit tab. HaXeZ will run. Blah 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 blah. Reverse shell option. After that, after you receive your shell, right click the host and select interact. This will open a standard shell you're familiar with in order to get a Meterpreter shell. Yep, so we can go back here and shell 1 and use interact, and that gives us a very slow shell, but a shell none the least. So if we head back over to here, we should have some question times. Practice time. Now that you have learned how to exploit the host using HaXeZ, you will need to get practice your skills by hacking virtual machine using Metasploit and HaXeZ. There are multiple exploit paths you may be able to follow. We encourage you to explore various exploit paths you may be able to find in order to gain better understanding of the exploitation and post-exploitation basics. In Metasploit and HaXeZ, as a reminder, HaXeZ is just Metasploit with a GUI, blah 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 blah. After gaining it, okay, so what we can do is this actually a Meterpreter based shell. Can I background it? Control Z. I thought it was supposed to be a Meterpreter shell, but if we what if we do cd administrator there, cd desktop there. Then we can do type root.txt, and that's how you get your root flag. Now, the trouble is, I was hoping Joe owns a session that it would put me in a Meterpreter session. Unknown command, who am I? Yeah, because this is how you should be able to dump the hashes. Now, it should have used a Meterpreter shell. Auxiliary scanner, I don't know. Post engagement. So, post engagement, let's see, Windows. Because what you can normally do with Metasploit or Meterpreter is you can just dump hashes, hash dump. There we go, let's try that. Session 1, launch. Session may not be compatible with this module. Well, it should be. Obtaining boot key, post failed, no method error. Interesting. MSF session, command shell, callback state. This module will create a reverse shell on the target using the system's own scripting environment. Launch, maybe? Okay. Try and drop that on there and launch that. Yeah, it still doesn't seem to want to get the hashes. But you could probably upload like Mimikatz to it or something and then get these hashes there, but those are your answers there. What flag can be found after gaining access to Ted's account? So we do still have a window open, right? Interact. Is this a session? So we just go cd user.txt and that's how you get Ted's file. Yeah, I'm a bit concerned about not being able to get the hashes, but hey ho, that's how it goes sometimes. Anyway, let's move on to the next task before we waste any more time. Hopefully you can poke around on it and find the hashes yourself. Task 7, advance C2 steps. Now I do apologise in advance for rushing through the last bit. I'm probably going to rush through this bit as well. The video's getting on quite a lot, so I just want to get to the end now, but most of the information has sort of been covered. Let's crack on. There's always room for improvement. As you may have guessed, Metasploit itself is not that great of a C2 server for advanced adversary operations. It is not flexible as one would desire. You cannot configure agents to beacon out every X seconds with XY jitter. A next generation firewall could quickly pick up on the C2 traffic, seeing its constant stream of traffic. In addition, anyone can connect to a HTTP, HTTPS listener and find out relatively quickly what's going on. Command control redirectors. What is a redirector? Before we dive into configure a redirector, first, what is it? A redirector is exactly what it sounds. It's a server that redirects HTTP to HTTPS requests based on information within the HTTP request body. In production systems, you may see redirector in the form of a load balancer. This often runs as Apache 2 or Nginx. For this lab, we will be leveraging Apache and some of its modules to build a redirector. Jumping back into Metasploit, we can set up some basic configurations on Metasploit to allow for more advanced configurations. In this task, we'll begin by setting up a redirector. Usually this configuration is set up on multiple hosts. The purpose for this is to hide the true command and control server. The diagram below illustrates how communications between victim and C2 happen. Okay, so I was sort of wrong earlier when I said about virtual hosts maybe. I don't know, it still seems like the same type of thing. Anyway, usually when you have a C2 callback, you may set the callback host to a domain, let's say admin.tryhackme. It's very common for your C2 server to get reported when the user files a complaint. Usually the server gets taken down fairly quickly. It can sometimes be as little as 3 hours or as much as 24 hours. Setting up a redirector ensures that any information you may have collected during the engagement is safe and sound. But how does this stop the C2 server from being taken down? Surely if someone fingerprinted the Cobalt Strike on your C2 server, someone would file a complaint and it will get taken down. That's true, so you should set up a firewall to only allow communications to and from your redirectors to mitigate any potential risks. That's cool, so setting up a load balancer to your C2 server. Imagine that gets complicated with listeners and things like that. How is a redirector set up? Before we dive into configuring a redirector, we must first understand how one is set up. We will be aligning this to the tools we have available, which are Metasploit and Apache 2. In Apache, we will be leveraging a module called mod rewrite. The mod rewrite module. This module allows us to write rules to forward requests to internal or external hosts on the server based on a specific HTTP headers or content. We will need to use several modules to configure our redirector. The following modules must be enabled: rewrite, proxy HTTP, and headers. No, if you are using attack box, there is already a service running on port 80. You must change the default port that Apache listens on in Apache ports.conf. You must do this before start using Apache 2. I'm probably not going to go through the labs on this one. The main thing I wanted to do was just set up Armitage. But yeah, feel free to do this in your own time. So yeah, you can see the install of Apache is going ahead. Using Meterpreter, we have the ability to configure various aspects of HTTP requests. For example, the user agent. It is very common for a threat actor to make slight adjustments to the user agent in their C2, HTTP, HTTPS payloads. It's in every HTTP request and they are more or less look the same, and there is a very good chance a security analyst may overlook a modified user agent string. For this demonstration, we will generate a Meterpreter reverse HTTP load using MSF-Venom, then we will inspect the HTTP request in Wireshark. So you can see that it's generating the request to shard.exe, the victim clicks shard.exe. After generating the modified executable and transferring it to the victim, open up Wireshark on your host, use the HTTP filter to view only HTTP requests. After it started capturing packets, execute the binary on the victim system. You will notice the HTTP requests come with our modified user agent. So you can see that get to that URL, and it's using a get request. Where's the user agent? Ah, there we go, user agent, Meterpreter. Cool. Now that we have a field we can control in the HTTP request, let's create an Apache 2 mod rewrite rule that filters on the user agent, not Meterpreter, and forwards it to our Metasploit 2 server. That's cool. Modifying the Apache config file. This section may sound intimidating, but it's actually quite easy. We'll be taking a look at the default Apache config and modifying it to our advantage. On Debian-based systems, the default can be found in etc, Apache 2, sites available. Yeah, so that's like virtual host, right? 00. Okay, so server admin, blah blah blah, directory. Okay, now that we have a general idea of the Apache 2 config and its structure, we must add a few lines to the config file to enable the rewrite engine and add rewrite conditions, and lastly pass through the Apache 2 proxy. This sounds fairly complex. I think it's just how a lot of sort of illegal streaming sites work these days as well. It's like with the referrer header instead. So if you get referred from a specific site, you can land on the site where you can watch the content, like wrestling or something like that. But if you try to visit the site directly, the video you get is completely different. but the site's still the same, so he's obviously mirroring the site over. Very clever. To enable rewrite engine, we must add rewrite engine onto a new line in the virtual host section, so it is virtual hosts. Now we will begin using rewrite condition targeting the HTTP user agent. For a complete list of the HTTP request targets, see the mod rewrite documentation on apache.org. Because we only want to match the user agent, not interpreter, we need to use the same basic regular expression to capture this. Adding caret signals to the beginning of the string and the dollar at the end of the series gives us the not interpreter. This regex will only capture the not interpreter user agent. We can add the line rewrite blah 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 to our config as previously stated. Only allow HTTP requests with the not interpreter agent. Okay, so it's checking not interpreter, anything but interpreter or something to that effect. Lastly, we must forward the request through Apache 2 through our proxy to Metasploit. To do this, we must use proxy pass feature of Apache's mod proxy. To do this, we need to justify the base URI that the request will be forwarded to, in case we just need / and the target we want to forward the request to. This will vary from setup to step up, but this IP address will be your C2 server. In lab scenario, it will be localhost on a port Metasploit is listening on. This will give us a full config that looks like so. So you can see there, you got the rewrite condition and the proxy pass, so it's going to localhost 8080. So the web server will be there. Sweet. Okay. Setting up exploit multi-handed. To set up Metasploit properly, interpreter properly, we need to make a few modifications. We must set our host argument to the incoming interface we are expecting connections from. In our lab, this will be 127.0.0.1. In the real world, this will be your public IP address or interface that your redirect will be connecting to, aka your public IP address. And our port will be whatever you like. For the lab, we will be using TCP 8080. This can be whatever you like in production. As always, the best practice is to run services over a standard protocol such as HTTP should run on port 80 and HTTPS should run on port 443. These options will need to be duplicated for reverse listener bind addresses and reverse listener bind ports. Next, we will need to set up override our host. This value will be your redirector's IP address or domain name. After that, we need to set the override our port. This will be the port that HTTP or HTTPS is running on your redirector. Lastly, we must set the override request host to true. This will make Meterpreter respond with override host information, so all queries go through the redirector and not to your C2 server. Now that you understand what misconfigured, let's dive into it. Yeah, that's a lot. Cool. After all this has been set up, running your Meterpreter reverse shell should now proxy your communications through the redirector. For awareness, the diagram below shows how our redirector is set up in our lab. As a reminder, in engagement, you will want to use multiple hosts and DNS records instead of IP address. This is getting to some complicated next level stuff, mind, because yeah, I know when you're trying to get shells back to IP addresses and it's forwarding it all on, how stable are those shells going to be? I'm sure people do this all the time though, and it's great. Right, and then we've got some questions which I've already answered. What is the setting name that allows you to modify the user agent field in Meterpreter? It's HTTP user agent. What is the setting name that allows you to modify the host header in a Meterpreter payload? HTTP host header. And again, I'm sorry I'm rushing through this, but it's almost 9 o'clock. I'm knackered. It's time to get this video done. I mean, it's going to be over an hour, so. Task 8, wrapping up. Thank you. Recap. In this room, you have hopefully learned a lot about command and control frameworks and will be able to take your knowledge gained within this room and apply it to the real world. I cannot talk or read. At the end of the day, almost every red team ops user and command and control framework. It's an essential part of every red teamer's toolkit, and we encourage you to go out and explore various C2 frameworks that were not covered and mentioned in this room. How to choose a C2 framework. After finishing this room, you may be left with some questions, and hopefully one of them is, how do I know what C2 framework to choose in my red team operations? There is no right or wrong answer, just a few general questions you should answer first. What are your goals? Do you have a budget? Do you need something highly customizable? Is off-the-shelf antivirus evasion necessary? Do you need the ability to create your own modules? Is built-in reporting necessary for you? You should then take the information to C2 Matrix spreadsheet and narrow down your selection based on the questions. If you find the premium C2 framework that meets your criteria, it's highly recommended you request an evaluation trial to find out. Right. Again, sorry that I have been fumbling words. I've literally been working on this video all day. The amount of times I re-recorded section 4 just because I was having so many issues with it, and then I did it on the attack box and it worked first time, so egg on my face. I should have just used the attack box straight away. But yeah, I also had like work to do today, and then I had to go and pick something up from a friend or a colleague, and yeah, it's just been a busy day, so this video is a bit late coming out, and the editing is just abysmal. I haven't put as much attention into it as I should have done. But anyway, this is the last room in the fundamentals learning path, I believe. Let's have a look. Yeah, so we've done fundamentals, engagements, red team threat, red team OPSEC, intro to C2. So now we're going to look through initial access. I hope we don't have to keep using Armitage through these. If we can just use Metasploit, I'd be so happy. But anyway, I hope you liked the video. I hope it helps you get through the steps needed to set up Armitage if you were struggling with that. I had a comment on one of my other videos asking me to specifically do this video. I'm sorry it's gone on for so long. Hopefully, you know, you can skip to the best bits and get the information you need from it. I'll try and be more sort of refined and better in future videos. Anyway, that's all I've got for you today. I'm going to go to bed. Kind regards.